In this podcast, we will look at entering and labeling the data, how to run full model stepwise in hierarchical regression, and interpreting the output. Remember, the golden rule in SPSS is one subject's data per row. In this example, we have 25 subjects, so we will need 25 rows of data in SPSS. We have 5 variables, so we will need 5 columns in SPSS. We need to label our variables, so click on Variable View and enter the variables as shown. Once you have labelled your variables, you can click on Data View and start entering your data. Once all the data has been entered, you are ready to run the analysis. Full model regression. You would use this when there is a relationship between the independent variables and the dependent variable, but there is no distinction between the independent variables. To run the analysis, click on Analyze, Regression, Linear. Click the dependent variable across, and click the 4 independent variables in one block. Check that the method says Enter. Click on Statistics and tick Descriptives and R-square change. Click Continue and click OK. You can use the Descriptive Statistics box to check that all the variables you wanted to enter into the analysis have been entered correctly, and that the corresponding numbers in each group match up. You can see that all the independent variables have been entered in Model 1. And you can also use this to check the method that has been used. In this case, it is Enter. As you can see, all the independent variables have been entered in Model 1. This shows the correlation between all the independent variables and the dependent variable. This shows that 73.6% of the variance in the dependent variable is explained by the independent variables. This shows that this is significant. You use the coefficients table to work out your regression equation. As it's full model regression, all the independent variables will be included in the equation as shown. You then substitute A and B with the values given in the table. If we wanted to be 95% confident in this prediction, we would use the equation shown to work out the range of scores for the prediction. Stepwise regression. You would use this when you are interested in the relative contributions of the independent variables once the relationship of the other independent variables have been accounted for. The independent variables that do not add significantly to the proportion of the variance accounted for will not be entered into the regression equation. To run the analysis, click on Analyze, Regression, Linear. Click the dependent variable ability across. Click all the independent variables in one block. Click on Method and choose Stepwise. Click on Statistics click Descriptives and R-squared change. Click Continue and OK. You can use the Descriptive Statistics box to check that all the variables you wanted to enter into the analysis have been entered correctly, and that the corresponding numbers in each group match up. You can see that the independent variable, drive, was the only variable which significantly predicted basketball ability, as it was the only one entered into the analysis. You can check that the method used was stepwise. This box shows the correlation between the independent variable drive and the dependent variable ability. This box shows that 70.1% of the variance in basketball ability is attributed to drive. This box becomes important when there is more than one model. This box shows that 70.1% is a significant proportion of the variance. Use the coefficients box to work out your regression equation. As drive was the only independent variable that was significant, this will be the only variable entered into the regression equation as shown. You then substitute a and b for the numbers in the coefficients box. This box shows the variables that were not included in the analysis. This is because they did not account for a significant proportion of the variance in ability. Only drive predicted ability. If we wanted to be 95% confident in this prediction, we would use the equation shown to work out the range of scores for the prediction. Hierarchical regression. The variables are entered into the equation in the order specified by the researcher. You would use this when the researcher has strong theoretical rationale for entering the independent variables into the equation before others. To run the analysis, click Analyze, Regression, Linear. Click the dependent variable ability across. In block 1, enter set, shoot and drive. Check the method says enter. Click next for block 2. In block 2, enter dribble. Again, check the method says enter. Click next. In block 3, enter vertical jump. Again, check the method says enter. Click on Statistics, R-squared change and Descriptives and click Continue. Press OK. You can use the Descriptive Statistics box to check that all the variables you wanted to enter into the analysis have been entered correctly, and that the corresponding numbers in each group match up. It is a good idea to check that the method says enter. You can see that in Model 1, drive and set shoot were entered. In Model 2, dribble, and in Model 3, vertical jump. This shows that there are 3 models in the regression analysis. These are the independent variables that are in each model. These are the correlations of each model with the dependent variable. This is the percentage of the variance in basketball ability that is attributed to each model. This shows the percentage of the variance in basketball ability that is accounted for over and above that of the variance accounted for by the previous model. This shows that only Model 1 is significant. Therefore, only 73.4% of the variance in basketball ability is attributed to drive and set shot. As only Model 1 was significant, this will be used to work out the regression equation. This shows the variables that were excluded from each model. As only Model 1 was significant, we will use the standard error estimate for Model 1 to work out a 95% confidence range.